Hello, everyone. The electronic device must be designed with a power source and a circuit to achieve the desired output. A stable and reliable DC-regulated power output can continuously supply stable and reliable DC energy, meeting the needs of the operation of the electronic device. Now, we will learn the production of one of the most used circuits in the DC-regulated power supply, namely, the single-phase bridge rectifier filter circuit. The task requires you to acquire a DC power supply's installation and debugging skills by utilizing the provided electronic components and analyzing the structures and working principles of single-phase bridge rectifiers and filter circuits. This lesson will be broken down into 4 parts. In the following, we will learn them one by one. 1. Preparation of practical training. 1. Learn the relevant rules of the training room. Students must strictly follow the training room rules to ensure experiment safety. 2. Preparation of practical training tools. A set of commonly used electrician tools, soldering iron, solder wire, etc. Practical training schematic diagram and working principle. Now, let's read the single-phase full-wave rectifier filter circuit diagram. The above is the circuit diagram. We will further our learning after reading the circuit diagram. Analysis and working principle of the single-phase full-wave rectifier filter circuit diagram. 1. Analysis. What is a rectifier circuit? It is a circuit that converts alternating current, AC, to direct current, DC. What is a capacitor filtering circuit? The voltage output through a rectification circuit contains significant pulsating flow components. It is usually necessary to take measures like parallel capacitors. The pulsating DC can be smoothed by utilizing capacitors' charging and discharging characteristics, and AC components can be filtered out. The output pulsating components are reduced, and the DC components are retained to make the output voltage come close to the ideal DC voltage, called filtering. 2. Working principle. The input power voltage of the transformer's primary coil is 220 volts. In the positive half cycle of U2, a forward conductive voltage is applied to diodes V1 and V4, while V2 and V3 are subjected to a reverse standoff voltage. In the positive half cycle of U2, a forward conductive voltage is applied to diodes V2 and V3, while V1 and V4 are subjected to a reverse standoff voltage. During the positive and negative half cycles of the input AC voltage, a single-phase bridge rectifier circuit has a current overload in the same direction, leading to full-wave pulsating DC voltage and current on the load. Therefore, it is also called a full-wave bridge rectifier circuit. Analysis and working principle of the single-phase full-wave rectifier filter circuit diagram are shown below. 3. Knowledge and skills supporting the task. 1. Crystal diode. A crystal diode is one of modern electronics' most used components. The main characteristic of the diode is unidirectional conductivity, that is to say, it allows current to flow through it in one direction only. The functions of a diode include rectification, detection, and voltage regulation. Various types of diodes are generally classified as follows. Identification and testing methods of diodes. A. Distinguish the polarity of the diode according to the appearance. Sometimes, the diode pattern is directly marked on the casing. Some have colored rings or dots marked on their casings, and the end marked with a colored ring or dot is negative. The polarity can be directly identified if the diode has a transparent glass casing, the end connected to the contact wire inside the diode is positive. B. Identifying diode polarity using an analog multimeter. When a diode is tested, the analog multimeter is generally set to a range of ohmega, R times 100, or R times 1K. The resistance measurement is high when the red test lead is connected to the diode's positive pole and the black test lead is connected to the diode's negative pole. Conversely, the resistance measurement is low when the red test lead is connected to the diode's negative pole, and the black test lead is connected to the diode's positive pole. A digital multimeter can be used to assess the diode's quality. In the resistance measurement block, set the diode buzzer position. The measurement block has two main functions. Firstly, it can test diode polarity and forward voltage drop across the diode. Connect the red and black test leads to the two pins of the diode, respectively. If there is an overflow, the characteristic is reversed. When measuring again after exchanging test leads, a 3-digit number should appear, represented by the diode's forward pressure drop in decimal. Thus, the polarity and quality of the diode can be judged. When the forward pressure drop is shown, the lead pin connected by the red test lead is the positive pole of the diode, and it can be further distinguished as silicon or germanium material according to the size of the forward pressure drop. Secondly, it can test whether the circuit is open or closed. When it is verified that the circuit is dead, connect the red and black test leads to two test pins, respectively. When the buzzer makes a sound, the circuit is connected. When there is no sound, the circuit is disconnected. 2. Capacitor. A capacitor is created from two conducting metal plates with an insulated dielectric between them. When a voltage is applied between two metal electrodes, the charge will be stored on the electrodes, so the capacitor is an energy storage component. Capacitors are one of the most widely used electronic components in electronic devices. The capacitor is a basic physical quantity, denoted by C and measured in farad, F. The general formula for calculating capacitance is as below. The specific formula for parallel plate capacitors. The formula for electric field strength between plates is below, and the capacitance calculation formula is below. Capacity indication. A. Direct indication method. Indicate directly with numbers and unit symbols. For example, 1 μF represents 1 microfarad, some capacitors use R to represent the decimal point, and R56 represents 0.56 microfarads. B. Literal symbol system. A regular combination of numbers and textual symbols represents capacity. C. Color coding method. Color rings or dots represent the main parameters of capacitors. Capacitors share the same color coding method as resistors. D. Mathematical counting method. Mathematical counting method generally consists of 3 digits. The first and second digits are significant, while the third is a multiple. The scalar value is 473, which is 47 times 103 equals 47,000 pf, picofarad. The following 2 and 3 represent the power of 10. The model names of capacitors in various countries are not uniform. The naming of domestic capacitors consists of 4 parts, which represent a name, material, classification, and serial number. Testing method of fixed safety capacitors. A. The capacity of a fixed safety capacitor below 10 pf, picofarad, is too small, so if using a multimeter to measure it, you can only qualitatively check whether it has leakage, internal short circuit, or breakdown. When measuring, you can use a multimeter R times 10K block. Use 2 test leads to connect the 2 pins of the capacitor. The resistance should be infinite. If the measured resistance value is 0, the capacitor leakage is damaged or internal breakdown. B. Test whether 10 picofarad to 0.1 microfarad fixed safety capacitor has a charging phenomenon, then judge whether it is good or bad. The multimeter uses are times 1K gear. The beta values of both transistors are above 100, and the penetration current is small. The silicon triodes, such as model 3DG6, can be selected to form composite tubes. The multimeter's red and black test leads are connected to the emitter E and the collector C of the composite tube, respectively. Due to the amplification effect of the composite triode, the charging and discharging process of the capacitor under test is amplified so that the multimeter pointer swing is increased. It should be noted that during testing, especially when testing small capacity safety capacitors, it is necessary to repeatedly switch the 2 points of the capacitor under test to contact A and B to see the multimeter pointer swing clearly. C. For safety capacitors above 0.1 microfarad, the R times 10K range of the multimeter can be used to directly test the capacitor for the charging process and internal short circuit or leakage, and the capacity of the capacitor can be estimated according to the amplitude of the pointer swinging to the right. In this lesson, we learned the practical production of single-phase bridge rectifier filter circuits, practical training principles, and working principles. We also acquired the supporting knowledge and skills for practical training. That concludes this lesson. Thank you, everyone.